All right. Here we go. Number 1. Cosine 5 pi over 6.
Cosine 150 degrees.
So first thing you have already done is change that into degrees so that you have a better sense of where it is. So cosine 5 pi over 6, that's the cosine of 150 degrees. If you don't understand something I put up here, I should see this, right? Don't just sit there. That's not working for most of you. Math is a participation sport. Okay, so then I'm going to draw 150 on my setup here. So 150 is going to be over here. I'm going to drop my perpendicular so that I have a triangle.
30, 60, 90.
How big is that
30.
angle?
30.
That's a 30, because it's between the 150 and the 180, so that's a 30. In a 30, 60, 90 triangle, across from the 30 is 1, hypotenuse is 2. Is this triangle in quadrant 1?
No.
No. Therefore, something has to be negative.
Negative.
That's negative. The 2, the hypotenuse, will never be negative, but depending on what quadrant you're in, the root 3 and the 1 can be negative. In this case, that's negative, right? I want cosine. Cosine is adjacent over hypotenuse, negative root 3 over 2. Okay? That is not hard. All right. B. Cotangent, 5 pi over 2. Or no, not 5 pi, just pi over 2. Cotangent, pi over 2. That's the cotangent of 90 degrees. 90 degrees is straight up. So I drew a circle because it's impossible to draw a triangle like this for 90 degrees, right? Our general rule of thumb, if the angle you want is on an axis, you're going to draw a circle. You can draw whatever circle you want, but I am always going to draw a circle with a radius of 1. And that means that point is always going to be 0, 1. This is the point. X is 0, Y is 1.
The radius is always going to be 1 first.
You can make the radius anything you want. I will always make it 1.
It's probably the easiest.
Yep, that's why I make it 1. I want cotangent. What's cotangent?
X over Y.
X over Y. So X over Y will be 0 over 1, which is 0. Now see, this quiz came from back in the day when I was a harder teacher. Look at that. Sine 287 pi over 4. You didn't have anything like that. Sine 287 pi over 4. 287 fourths is a big number, right? 287 divided by 4 is 71.75. So it's 71 3/4. So if I wanted to start trying to draw that, what is this going to do? It goes round and around and around, right? Every time it goes around, it's 2 pi. 2 pi. So I'm going to start getting rid of 2 pi's here. Don't keep that big, huge angle. There's no sense in it. If you change that into degrees, then you'll get rid of 3/60. I'm just going to leave it radians for now and get rid of 2 pi. But you could change it to degrees and get rid of 3/60. Those are just spins. So a spin is 2 pi. So how much of that can I get rid of?
Be in the
I
fourth,
can get rid of
35.
70
35.
pies.
It'd be in the fourth quadrant, right?
I can get rid of 70 pies. Because what is 70 pi? 35 spins. Whoop, 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 35 times. I'm just gonna ignore that. So now I'm thinking of this as 1 3/4,
Yeah.
which is 7 pi over 4. And then I'm right back to where I was over here. I want the sine. So it's gonna be the sine of 315. 7 times 180 over 4. If you changed the original number, the big fraction, into degrees, and started subtracting 360s, got rid of all the 360s, it would be left with this. Somebody's already said 315 is in quadrant 4. Reference angle is how big? 45. 315 to 360. What's negative?
The opposite.
This guy right here. I want sine -1 over root 2 or -√2 over 2.
How'd you find the 315 again?
7 times 180 divided by 4. All right? If your angle is too big, get rid of the parts you don't need. And what can you get rid of? Revolutions. 2 pi's or 360s. Find a positive coterminal angle for 8 pi over 11. I remember standing up here saying to you,
So
to find coterminal angles, we add or subtract a revolution. If I am in degrees, I add 360. If I'm in radians, I add 2 pi. This problem that we just finished, I started with a great big angle, and what did I do? Took out revolutions. I found a coterminal angle, the smallest one I could get down to.
for the last problem, did you not just do 180 divided by 4 times 287 because of how big the number is going to be?
I
Could you have
said
done
you
that?
could do that,
Okay.
but then you have to get rid of all the 360s.
Okay. It was just easier to do that.
And no, not easier. I chose to do it that way
Okay.
because I'm not tied to my calculator so much, and it's
Okay.
easier for me to deal with getting rid of 2 pi's than it is to getting rid of 360s.
Okay.
But it's fine. Either way, it doesn't matter. The point is, you gotta get rid of those extra revolutions.
Okay.
You're gonna get 315 no matter which way you do it. Or you better get 315. All right, I have 8 pi over 11. I'm gonna add a revolution, so I'm gonna add 2 pi. Right?
30 pi over.
So 2 pi is, that's 2 pi over 1. So that's 22 pi over 11. So when I add, I get 30 pi over 11. That is a positive. What if I needed a negative?
Subtract.
Instead of adding 22, I would subtract it. So the negative one would be negative 14 pi over 11. Didn't ask for that, but that's what it would be. How many radians is 20 degrees?
5 or 6. Pi over 9.
Pi over 9,
Yeah.
Sam, very good, pi over 9. Now, Sam thought about it. 20 is what fraction of 180? 1/9? So we said, okay, it's 1/9 of a pi. If that doesn't make sense to you, you can always do pi over 180 equals x over 20. You can always do that. If the number is something weird like 17, I would definitely do this. But since 20 is 1/9, it's easy to do that way. Okay, my friends? Turn it over. Alright, find the values of the 6 trig functions. Okay, so we're finding sine, cosine, tangent, cosecant, secant, and cotangent. And we know that sine is 2/3. And we know that tangent is negative. So the first thing we gotta do is figure out where our did I remember to turn this on? My brain is not very good. First thing I just figure out where we're gonna draw this picture. So does anybody have a thought about where we might draw this picture?
Triangle.
The first
It's gonna be a
quadrant.
triangle. It won't be the first quadrant. Now, I love the first quadrant, that's my gut feeling, but the problem is this. Will the tangent or anything be negative in quadrant 1? No. Now, the sine, I could have, that could work. But it doesn't fit that. So it's not quadrant 1. Dana says, what about over here? Well, think about that for a second. Over here, can the sine still be 2/3?
Yeah.
Only now, this side will be negative and the tangent will be a negative number. So that's the picture you're gonna draw. So you have to think, you have to logic, you have to think about it. All right, so now we're gonna find this side and we're gonna find it by doing what?
Pythagorean.
Pythagorean theorem. Remembering that these are A and B. That's C. So, what do we got? What'd you come up with?
Root 5.
Negative square root of 5. You came out with root 5, but we know it's negative because of where it is. And now we can just fill it in. So what is cosine? Which is
Negative 5/3.
negative root 5/3. And tangent,
Negative 2/5.
2 over negative root 5, or negative 2 root 5/5. Are we good? And then our flips, cosecant is 3/2. Secant is 3 over negative root 5, negative 3 root 5/5. And cotangent is negative root 5/2.
Can we have to do it in 2 different quadrants because it can be opposite orders and it's negative?
Yeah. If the tangent's negative, then either the top or the bottom's negative. It doesn't matter which one. So then your question is, could I be in a different quadrant? Okay, no. Because if I'm in a different quadrant, like what quadrant were you suggesting?
The bottom right.
Okay, let's call that quadrant 4. Okay, down here in quadrant 4. All right, what's wrong with this?
The root 5 would be positive.
And that's okay. The problem is the 2 will be negative. And I need the 2 to be positive. So that, London, you're right, that would give me a negative tangent, but it doesn't give me a positive sign, and I need that. So when you do one of these problems, London, they'll be notified if you're wrong. Okay? If you're getting 2 pieces of information like that. All right, number 5. No arc length. What is my general formula when somebody says arc length? What do I think?
Radius.
Yeah, radius times radians. Now, the first problem tells me that the arc length is 16, so that's the arc length. And theta is pi over 3. So I can either divide by pi over 3, or I could times by 3 and divide by pi. It makes absolutely no difference, but there's your answer. The second one says that my radius is 10 and my angle is 30 degrees. And I am going to find my arc length. Now the radius is 10, and I need to multiply that by the radian measure of the angle. So I can either set up my proportion, pi over 180 equals x over 30, right? Or I can use my head. 30 is what fraction of 180? 6? So isn't this just going to be pi over 6 radians? So what's the answer to the question? So it's 10 pi over 6, which is 5 pi over 3. Right?
Good.
All right, number 6. I want you to spend some time figuring this out. Let's look at what we got. We have a triangle. This is B, this is A, this is 40, this is 15. And we need to know which of those equations will give me an A value. So A equals what? So take a second and do that. I'm going to come around and check uniform to make sure we're in the spirit of the day. What are you supposed to be doing today? Huh? Wabash is not an IPS school.
Oh, that is
Yeah.
You guys,
Your mom is for it.
no, the whole thing is supposed to be,
You can put my name on there too, Jaden Greenwell. Is it in practice?
not you, because you've got something there.
After Hard Mary.
After Hard Mary. Your West Coast. What's your throwback? You're even a junior, right? Aren't you a junior?
Yeah.
Okay, you can't act like these people.
Oh.
Any of my,
Are you in uniform? No. Is anybody in here in theme? I'm just gonna write
Yes.
everybody. Okay, if it doesn't show, it
Oh,
doesn't
gotta
count.
take my shirt off.
But mine counts.
You're fine,
Mine
you're
counts. I'm
amazing.
good.
Sam, I thought
This is
you.
what I, this is
I-
what I
There's
guess.
one right there.
Let's
IHM's rocking it here.
go. Represent.
You are, but you're allowed to not,
Yeah,
because of your legs, so I'm not gonna get you. You're allowed. She's even allowed to be out of uniform, and she's in, she's in thing.
Wow. That's
St. Matthew?
Mine doesn't have my school name, but it came from my school.
Nah, that ain't gonna work.
What is that? What is your school?
And I was Westland, but we got,
Okay, so what does that mean?
Bro,
it was
went to
a
IPS
thing that
for
went
week,
through
we were
with
college
Westland. We
students.
got these shirts for our
I went to
parents.
JH House Part 2, that ain't.
I think this should count. I thought Westland was
Fine.
This should count. If I take my sweatshirt off, this counts. If I take my sweatshirt off, this counts.
This is what IPS let us win.
It's 4. If I take my sweatshirt off, this counts.
I got nothing against you.
It's 4. If I take my
Dana,
sweatshirt off,
I got St. Luke, yes, sir.
Dana High.
St. Luke strong.
Okay, get it off, and it counts. If it's in grade school,
Yeah, it's easy.
Okay, then.
Take it off. We should have like flexes and such.
Look at this, look at this, uniform.
I don't think Jay's in.
I think they're massive.
I'm in my way.
I know it's far away, bro.
Wait, what if you went to college for a and I came back to finish my
You got
We loved it so much, we're all just gonna move.
What, look, he's either, he's got a uniform. All right, you guys, come on. Tomorrow, we have class, I'll be checking again tomorrow. So if you choose to be out of uniform, then you have to be in the theme of the
If I was here,
day.
I
All right. Tell me what you came up with.
D for Dana.
Oh yeah, I can remember.
For Dana. Yes,
No, I don't get
Dana says this one works. Well, let's check it out. In this picture, the cosine of 40 would equal A over 15, right? And if I bring the 15 over, D is correct. So D is one of the answers. Did anybody find another one? C? C says, C involves sine. So the sine of 40 would be B over 15. So B equals 15 sine 40, not A equals 15 sine 40. So C is not right.
What? D's not right?
D is right. There's two of them now.
Oh.
Read the directions. There's two of them.
Oh, I read
Which one?
C doesn't work?
Oh, no,
I haven't done
it's
C
50.
yet. Oh, yeah, C doesn't work. C doesn't work. I did C.
It's A, it's A, it's A.
All right. No, remember, if that angle's 40, this angle's 50.
It's
So if you think A works, the sine of 50 would be A over 15.
A. Yep.
So A equals 15 sine 50, so that is correct. So the answers are A and D.
D for Dana's amazing. A is amazing. Oh, really? Dana? I take Shepard. That's what his name is.
All right,
Direct with information.
we'll be having another quiz after we finish 4-5,
No, we're not.
which is our next section. Because of all this extra review I've done, I don't have time to have a full-fledged test. So I have a bit like a quest over 4-5, and then we'll have a test over the whole chapter, okay, which is, or 7, I think is the last, or 8. So, it's time to buckle down.
We're doing notes now?
We're doing notes now, we're back to our notes. I ran off some other review materials, we'll be doing a bit of review periodically. But we also have to do. All right, number 4. You know what? Given our situation, I'm gonna not do problem 4. All right, so we're moving on to 4-5. 4-4 homework will be due on Monday. And now we're going to sketch the reciprocal functions. All right, so this is part of the problem. We already know what sines and cosines look like. Today we're going to get the other 4 shapes. So that's what A, B, C, and D are, the other 4 shapes. So y equals tan x. this is what you need to know. It has an asymptote and an asymptote and a squiggly line up through the origin. Tangents look different than sines and cosines. The asymptotes are at negative pi over 2 and positive pi over 2. So this part, number 1A, this is your standard curve. As you can look down the page, we'll be sticking numbers in, and those numbers will do the same thing that they did with the sine and cosine. But this is the shape we'll be starting with. Now, tell me about amplitude and period for this.
Amplitude is infinite.
Yes, and because it's infinite, we say actually there is no amplitude. Amplitude is height. And this curve really has no height. There's like no stopping point. There's no label. This axis has no labels on it. Okay, so no amplitude, ever. Okay, hang on to your hats. We're going to discover that the only curves that have amplitude are sine and cosine. None of the rest of them have amplitude. So for B, C, and D, amplitude's going to be none. The only curves that have amplitude are sine and cosine. How about period? What's
Pi
our
over
period? Not pi over 2.
Oh.
It's actually pi, because this is a period.
Okay, yeah.
And it's from negative to positive. Now, our sine curves, we said the period was 2 pi, but that's because we were starting at 0. So that literally is 2 pi. Here, the period is pi, because we're starting at negative 1/2. Does that make sense to everyone? Okay. Now, what about cotangent?
That's still a 0.
Cotangent has an asymptote on the axis, another asymptote at pi, and a squiggle that goes down through the point pi over 2. That is a cotangent. Now, let's give you a chance to look at that, get it drawn. Does the shape of that at all make sense to you?
It's the opposite.
It's the upside down. Isn't cotangent upside down of tangent? So it makes sense that the picture would be upside down. It's been shifted because with tangent, remember, is y over x. So it has asymptotes when x is 0. Cotangent is x over y, so he has asymptotes when y is 0. That happens in different places. So, negative pi over 2 to pi over 2? 0 pi. What's my amplitude for my cotangent? None. So please don't put 0. You either write empty set or you write the word none. There is no amplitude. And then period, how far is it asymptote to asymptote? Pi. Same as this one. The asymptotes are just in a different place, but they're the same distance apart. Yes, so the shape of it, this one is actually the cubic function, yeah. The shape of it is exactly that, except the cubic function does not have asymptotes. So this one's kind of contained, but yes, you're right, it is the same general shape. All right, I'm gonna do these out of order. I'm gonna do cosecant first, because I always think it's a little easier, so I'm gonna do D first. If you have a colored pencil or a pen, you might consider getting it out. You don't have to, it just might help. First thing I want you to do is, if you're not gonna use a colored pencil, then do this very lightly. I want you to draw your sine curve. Okay, so draw your regular old standard sine curve. So I'm going to draw it with kind of a dashed line. That's my sine curve. Does that make sense to you?
Yeah.
Now I am doing, make sure you're on problem D now. I'm going out of order. This is D. I am doing a sine curve because the sine is the reciprocal of the cosecant, right? Sine and cosecant. So I'm starting with a sine curve. Now, every time you cross the axis, so here, here, and here, I want you to do an asymptote. So draw in an asymptote every time you cross the axis. Then, keeping in mind that the cosecant is the reciprocal of the sine, these are like cuts. You like cut your picture up. Take this hill and flip it over. When you flip it over, it becomes a parabola like that. And then guess what's going to happen here? Same thing. It's going to be a parabola opening down. Your cosecant is a series of parabolas. Up, down, up, down, up, down. Yep. Okay, so we started with a sine curve, dropped in the asymptotes, and flipped. So what about amplitude? None, zero, zero, zero. Amplitude is height. How high does that picture go?
Infinite.
Infinite. Now, is 1 an important number? Yeah, because that's like the low point of my upward parabolas, but that is not the amplitude. The amplitude is height. This curve has no amplitude. If you were listening to me a minute ago, I told you that. What has amplitude? Sine and
Cosine.
Nothing else. All right, what's my period?
2 pi.
2 pi. Yeah, perfect.
Trying to learn.
All right, let's do last one is secant. And you can probably guess why this one bothers me, or why I think this is a little harder. The the cosine curve is strange. There's my cosine curve. Now, who remembers, once I graphed my sine, what was my next move?
Draw upwards, bro.
Well, no, I didn't do that. Well, I did something else first. I just put in the asymptotes. And where do the asymptotes go? Where you cross the axis. So there's going to be an asymptote here and an asymptote here. Now, I have no issue with this parabola. I mean, that one's easy, right? Would you agree? It's these other two. This, if you think about that, this looks like this, because the other half would look like that, right? And then same thing over here. This looks like this, because the other half would look like that.
Oh.
So it's very odd looking. It's still an up parabola and a down parabola, but the up parabola has been split. Half of it's over here and half of it's over here.
Can you pass by your quiz today?
No, because he hasn't taken it yet.
Oh.
And I gotta write a new one, because because you didn't make it up when you were supposed to, now we got issues, so we'll deal with that another time. Okay, all right, we all right? Okay. Now we're going to look at E. going to do 2 tan, 2x.
Don't say there's.
So, the tangent has an asymptote here and an asymptote here, and a curve up through the origin. Would you agree with that?
Yeah.
Now, see that 2 right there?
Yep.
With the sine or cosine, that 2 would do what?
Push it up. Go up to.
It would change the amplitude,
Yeah.
right? Change the height. But what do we know about tangents?
They don't have amplitude.
They don't have amplitude, so we're gonna ignore that too. Now, I want you to understand, in reality, what's happening is this curve is being straightened out because of that. It might look more like this, but I am not expecting you to do that on your little sketches. So we are simply going to ignore that too. The only time we won't ignore it is if it's negative, because what would it change if it were negative?
Foot.
It would turn it upside down and make it look like a cotangent, right? But otherwise, forget that one. This one, however, is important. That divides, remember, this is a divider, that divides these labels, right?
Yeah.
Now, normally, this would be negative pi over 2 and pi over 2. But now they're being divided by 2, or halved, basically cut in half. So this is negative pi over 4 and pi over 4. So my amplitude is still none. And my period now, how far is it from here to here?
Pi.
This is pi over 4 and this is pi over 4. So wouldn't it be 2/4 or 1/2? Half the normal period's pi, and now it's half of that, because of that right there. Oh my goodness, look at that. We have hit the big time here.
No, this is like, you don't even gotta worry about the first one. You ain't gotta worry about that.
Now, I want you to be careful about saying not worrying about it. This is a cosecant. So what do I start with? I don't just jump in. I mean, I do this for a living. I don't just jump in with a cosecant. Where do I start?
Amplitudes.
I start with a sine. Right? Because I know what sines look like. I'm going to drop in asymptotes and flip my curve. So I'm going to pretend for a moment that this is negative 3 sine 1/2 x minus pi over 3. All right, so here's some review. We should know how to do this. Tell me what's going through your mind. Amplitude's 3. Okay. Starting at pi over 3. Perfect. Ending somewhere. It's negative, so would you agree it's going to come down and then go up? Are we good with that? So let's go ahead and figure out the labels. What's my period going to be? My period's going to be careful, 2 pi divided by 1/2, which is 4 pi. Sine and cosine have a period of 2 pi. Tangent has a period of 1 pi. Oh my gosh, there's so much to remember. That's why we got to study every night. So what does that mean? That means from here to here is 4 pi. So I'm going to find this number right here. I'm going to find that number right there by taking pi over 3 and adding 4 pi. So pi over 3 plus 4 pi. So pi over 3 plus 12 pi over 3, 13 pi over 3.
So 13 pi over 6 is
This is going to be in the middle of 1/3 and 13/3.
Oh.
So what's 1 and 13?
14.
14, and half of 14 is, so this is 7/3. What's this one? 1 and 7 makes 8. That's 4. And 7 and 13 make 20. So this is 10. We talked about, I know a lot of things. One thing we talked about was, look, from 1 to 4 is 3, and from 4 to 7 is 3, 7 to 10, 10 to 13. It'll always be that way. They have to be the same distance. All right, so there's my sign. It's all done now. There it is. Now I'm ready to make it a cosecant. Okay, so what do?
Draw a dash over the zeros.
Draw my asymptotes wherever I cross the axis. Those are called the zeros, wherever I'm a zero. So here, and here, and here. And then,
Asymptote through.
flip them.
So that blue line isn't an asymptote? The one where you drew through like 4 pi over 3 and then 13 pi over 3?
No, that's my label for my low point here.
So really, no, like that whole blue line that we start at pi over 3. Is that
This blue
yeah,
line?
Is that dashed?
Yeah, I mean, I did it in blue, but yeah, that is not part of the graph. The actual graph is only the black.
So we
So
draw
it's
that.
not necessary to draw the blue.
No,
Make it easy.
I mean,
I don't know if I can do this.
I know I can't, but I'm not, I mean, you guys can go ahead. This is the black. So I like to do it in color so I can tell what's what. If you're doing it just with your pencil, just make sure this is darker so I know that's your actual answer. The rest of the stuff is just kind of help me get there.
On the test, are we allowed to use a different color?
Absolutely. All right, let's do, you know what? Let's do this. Put your notes away. You got a half sheet of paper. Sure, okay. You need this paper you're going to turn in. No, you can't have that. You can shoot your notebook paper out. If you don't have one, see if you know somebody that has one, good, and share. We need a half sheet of paper. Patton, move back.
So a little pop quiz?
Jay, you come up here. Come up here. Dana, go sit in my chair. Jake, sit in the hall.
I'm on a game, guys.
Owen, you're out in the hall on the opposite side of the line. Essentially, you're gonna have to move because I can't make you move, so.
Where do we go?
Oh, go out in the hallway somewhere. You need the Grace. Stay in out in the hallway somewhere. Alright, here we go. Step on it. And by God, you gotta get this right. Here is your problem. Everybody's doing the same problem. We are finding, we practiced this today. We are finding, you're up here.
One
There's a
problem?
bad.
You gotta stand up.
There's only one problem?
Yes, and the problem is, find the cosine
Oh, I gotta
of 5 pi, no, 2 pi over 3. Find the cosine of 2 pi over 3. You guys spread yourself out. Cosine 2 pi over 3, one problem. Bring it to me when you are done. Cosine 2 pi over 3, no one needs a calculator for that. Cosine 2 pi over 3, take your time.